Hello, I'm Cameron.
And I'm Tanae, and this is our state management video for Apes for Alabama. Let's begin with solid waste disposal 8.09. To begin, we must identify the primary disposal method, landfill dominance. Landfill accounts for 66% to 84% of the state's waste, fueled by exceptionally low tipping fees, approximately $1 per ton, and a massive infrastructure that accepts both local and out-of-state refuse. In terms of diversion targets, despite the heavy reliance on landfills, Alabama has set a 2026 goal to reach a 33% diversion rate by shifting more municipal and industrial waste toward recycling and reuse. In terms of describing it, landfill design features in the state have containment and protection. Modern facilities are built as sanitary units using a composite bottom liner with reinforced plastic and compacted clay to shield groundwater from contamination. Additionally, in terms of active waste management, to maintain site integrity, landfills must operate leachate collection systems to extract contaminated liquids and stormwater controls to divert rainfall away from the waste mass. For closure and emission control, once full, sites are sealed with a multi-layered synthetic cap and equipped with methane collection systems to manage greenhouse gas emissions and ensure long-term environmental stability. In terms of analyzing the impacts, we must address specific environmental effects. For example, there's environmental injustice. Facilities are frequently cited for their disproportionate impact on the low-income and minority communities, such as Uniontown, which serves as a massive repository for hazardous waste and out-of-state coal ash. In terms of atmospheric and health risks, landfills emit potent methane gas, which is 80 times more effective at warming the planet than carbon dioxide over 20 years, alongside odors that trigger local health issues like nausea and chronic headaches. In terms of water contamination, there is a persistent threat from leachate leakage and coal ash storage in unlined pitch, which can release heavy metals like arsenic and lead into groundwater, threatening the safety of private wells and Alabama's overall river systems.
So, this brings us to the waste reduction methods of 8.10. In data gathering, the recycling rate, Alabama's current diversion rate is approximately 33%, which is a massive 2026 goal and is a massive jump from the stagnant 8 to 10% rates seen in previous decades due to improved municipal reporting and infrastructure grants. So this brings us to the program status. The state does not have a bottle bill, mandatory center producer responsibility, or a statewide pay-as-you-throw mandate. Composting remains limited to local, municipal, and university programs rather than a state-run system. And connected to Apes concepts, the source reduction is Alabama's push for a 33% diversion rate and aligns with the concept of reducing waste at the source, emphasizing that minimizing municipal waste generation is the most effective way to lessen environmental burden. This brings us to diversion versus disposal. By shifting the focus from landfilling to recycling and reuse, the state aims to mitigate the environmental trade-offs of landfills, such as methane production from anaerobic decomposition and the leaching of heavy metals. And this brings us to identify, slate, and evaluate. So the policy managed by ADEM and ARF utilizes a portion of the state's solid waste disposal fees to provide grants to local governments for expanding recycling equipment, education, and collection programs. The effectiveness is that this policy has been highly effective since the passage of the Solid Waste Management Recycling Fund Act. Compliance rates at landfills have rose to 96%, and the state has successfully tripled its recycling rate by funding over 25 major local programs.
Now let's move on to sewage treatment for 8.11. To identify the levels used, primary and secondary focus. Alabama's municipal facilities primarily utilize secondary treatment as a regulatory standard through large urban centers or sensitive watersheds like those near the Gulf Coast. However, they can also implement tertiary or advanced treatment to further remove nutrients such as nitrogen and phosphorus. To describe the mechanisms, in terms of physical and biological processes, treatment begins with primary sedimentation, where gravity separates soluble solids such as sludge from the liquid. This is then followed by secondary or biological treatment, typically using activated sludge or trickling filters, where aerobic bacteria consumes organic pollutants. And now let's move on to disinfection and discharge. Lastly, prior to discharge into Alabama's waterways, water is disinfected using either chlorination, the most common method, requiring later dechlorination, or UV radiation, which scrambles the DNA of pathogens without adding any additional chemicals. Lastly, let's talk about disinfection and disposal. In terms of management of these solids, residual biosolids or sludge are stabilized through anaerobic digestion or composting and are typically disposed of via land application as fertilizer, landfilling, or in cities such as Huntsville through incineration at waste-to-energy facilities. Let's talk about water quality challenges. A major issue in Alabama is sanitary sewer overflows, or SSSOs. For instance, in the Alabama Black Belt, failing infrastructure and impermeable clay soils frequently lead to raw sewage spills during heavy rains, causing significant E. coli contamination in local streams.
And lastly, that brings us to the sustainability evaluation paragraph. So Alabama's waste management is currently unsustainable because it relies on extremely low tipping fees, which prioritizes cheap landfilling over high-value tiers of waste hierarchy. While the 2026 goal of 33% diversion rate shows progress, the mass influx of out-of-state refuse and persistent coalition abilities create long-term ecological risks and outweigh these gains. In text to adopt one policy, I recommend the Alabama Recycling Fund, which analytically converts the negative externality of landfilling into a direct funding source for municipal infrastructure. This mechanism is superior to simple mandates because it provides the liquid capital necessary for rural regions to bridge the infrastructure gap between waste generation and recovery. By earmarking disposal fees for recycling grants, Texas can mirror Alabama's success in tripling its diversion rate through targeted self-sustaining local investment. Thank you.